In our home automation series so far, we've built our smart home using OpenHAB and we've applied enterprise security practices to it. But we have a problem. The problem is the MyOpenHAB cloud service, which is an incredibly handy method of linking our home into services like Amazon Echo and the Google Voice Assistant. It's great, but not for its security, and using it backdoors all of the work we've done so far. But you and I, we're not so easily defeated. So in this video, we're going to fix the cloud. Welcome back to the ProTech Show. This is the third in a series of videos about building a smart home using OpenHAB. The previous two are linked in the description, so I recommend you watch those if you're new. But here's a quick recap on where we are. We've built a home automation server using OpenHAB as the platform. Actually, we built two of them, one on Linux and one on Windows, just so you could see both, but we only actually need one of them. Then in front of OpenHAB, we put a Kemp Loadmaster. Preferably this would be in a DMZ, but for the sake of simplicity, we didn't actually do that. The Kemp Loadmaster handles encryption, it adds multi-factor authentication using a username and password plus a mobile app prompt, and it uses a web application firewall to inspect network traffic for attacks. Any access to OpenHAB from the public internet is routed through the Kemp Loadmaster so that nobody gets access unless we say so. If this seems like a lot of effort, there is a much easier way, using the MyOpenHAB cloud service. That's not MyOpenHAB, it's MyOpenHAB, all one word. This is free and just works without requiring any real knowledge on your part. As I explained in the last video, I don't feel comfortable using it because it uses weak single-factor authentication. A password is not good enough these days. So we built all of this and took control of our own security, but then we hit a snag. See, one of the really nice things about OpenHAB is just how easily it integrates with the Google Assistant and Amazon Echo. Other self-hosted home automation platforms require you to sign up for developer accounts and build your own custom integrations that are subscribed to a paid cloud service. MyOpenHAB basically does the latter, but it's completely free. Unfortunately, the MyOpenHAB cloud service has no real concept of the principle of least privilege. It requires you to fully trust it with unrestricted access to your smart home. That's not okay. From a security standpoint, it's saying that in order to operate a light switch, it needs access to my heating controls and the video feeds from my cameras. No you don't. This is because the OpenHAB cloud service that MyOpenHAB is based on has just one toggle to enable just notifications or full remote control, and that's it. If you didn't see the previous video, this might sound like I'm just having a grumble about MyOpenHAB. But the reality is, I have no grounds to complain. I don't pay for it, it's free. And it's not one of those services that's free because you're the product. If I were a professional software developer, the right thing to do at this point would be to start writing the code to provide the access control I wanted it to have and contribute that back to the project. I'm not a developer, and security on a publicly available service probably isn't the best place to learn, but I do know network infrastructure and we've already built our own security layer. The interesting thing is that we can actually use the security layer to filter the traffic from the MyOpenHAB cloud service and force it to obey our rules of least privilege. So I'm going to show you how to take advantage of the service provided by MyOpenHAB, but in a way that keeps you in control of what it gets access to. That's going to be my contribution. To understand how we're going to do this, we need to know how the OpenHAB cloud works. In fact, let's quickly enable it. On your OpenHAB server, go to Settings, Add-ons, Other Add-ons, and install the OpenHAB Cloud connector. Go back to Settings and you'll now see OpenHAB Cloud under Other Services. You should be able to leave everything at default, but make sure the mode is set to notifications and remote access. Now go to myopenhab.org and create an account. You'll need a UUID and a secret. You'll find these in files on your OpenHAB server. They'll either be under your user data folder or var lib openhab, depending on how you installed it. The UUID is in the root of that folder, and the secret is in a subfolder called OpenHAB Cloud. Now if you click on the link to access your dashboard, you'll have remote access to your OpenHAB server from the cloud. This is incredibly easy compared to the way we did it, but it's also a bit scary, because there's no way to enable multi-factor authentication, and there's no way to disable this full remote access if we just want to use a Google Assistant or Amazon Echo. But how did it even work? Unlike the remote access we've built, MyOpenHAB doesn't require any DNS records or any firewall ports to be opened. This is because it does some clever tunneling. When you use any website, the conversation between your computer and the website consists of requests and responses. You send a request asking for a page, and the website returns a response containing the page. This is how it works with our remote access solution. The remote user sends through a request, Kemp verifies their identity and checks it for threats before passing it to OpenHAB. Then OpenHAB sends back a response which Kemp passes to the original client. When you enable the OpenHAB Cloud option, your OpenHAB Cloud connector makes an outbound connection to MyOpenHAB. This is why you don't need to worry about DNS or firewall ports, because you're making the request and the firewall stuff is happening at the other end. But what request are you sending when it's a remote user wanting access to your network? Basically, your OpenHAB server sends a request saying, "What do you want?" If there is a remote user connecting to MyOpenHAB, they'll also send a request to MyOpenHAB asking it for something. Perhaps they want to know the temperature in the living room. MyOpenHAB takes the remote user's request, wraps it up inside a response, and sends that response as an answer to the request from your cloud connector that asked, "What do you want?" The cloud connector unwraps the response, gets the remote user's request, and passes it to OpenHAB. At this point, OpenHAB behaves normally. It receives a request asking for the temperature in the living room, so it replies with a response that contains the temperature in the living room. The cloud connector receives that response, wraps it up inside a request, and sends it to MyOpenHAB saying, "I have a request. The living room is 20 degrees. What do you want?" MyOpenHAB unwraps the request, sends a response to the end user, and you're back at the beginning. It's quite clever. The OpenHAB Cloud Connector turns the normal request-response cycle upside down by putting requests inside responses and vice versa. This means you don't have to worry about firewalls and DNS, but it also means that all of these connections have a backdoor into your network that bypasses the Kemp security layer. These requests are getting transported through the OpenHAB Cloud Connector unchecked, and when they pop out the other end, they're inside your OpenHAB server and they're completely trusted. We have to do something about this, so we're going to hijack the cloud requests as they come through the tunnel. The point at which you want to spring that trap is right after they exit the tunnel, here. As soon as the original request pops out, we're going to kidnap it. Let's take a closer look at how the OpenHAB Cloud Connector forwards the external requests to OpenHAB. It is hard-coded to use the address http localhost on whatever HTTP network port OpenHAB is using. As I'm sure many of you will know, the name localhost resolves to the IP address 127.0.0.1. This is the loopback address that always refers to the local computer. 127.0.0.1 on your computer is your computer. 127.0.0.1 on my computer is my computer. Every computer has this address, but they'll also have a normal IP address they use on the network. Because every computer thinks 127.0.0.1 belongs to them, you can't use it to talk to anybody else. By default, OpenHAB will listen for connections on all IP addresses the computer has, including this loopback address. But we can change that. We need to edit the file org.ops4j.pax.web.config. Have a look for the line org.ops4j.pax.web.listening.addresses. By default, this will list the IP address 0.0.0.0. That's not a real usable IP address. It's used to mean listen on all IP addresses. Delete the hash sign at the start, that's pound for the Americans. Change it to the specific IP address of your OpenHAB server and restart the OpenHAB service. This means OpenHAB will continue listening on that address and will be accessible on the network, but it will not be listening on the loopback address anymore. When the OpenHAB Cloud Connector forwards the external request to localhost, nothing will be listening for it. That's step 1. Step 2 is we're going to take OpenHAB's place on localhost. The way we do this depends on our operating system. Windows is the easier one here because we just need to run a command. Open a command prompt running as administrator and type the following: netsh interface port proxy add v4 to v4. Listen address equals 127.0.0.1. Listen port equals 8080. Connect port equals 8080. Connect address equals, and then a spare IP address on your network. If you changed OpenHAB's default HTTP port, then substitute your port number in for 8080 on the listen port parameter. What we've done is we've told Windows to listen on the localhost port previously occupied by OpenHAB and to forward any traffic it receives to another IP address on the network. That IP address doesn't exist yet, but first let's repeat this in Linux. I'm going to do it differently this time. Linux can forward ports, but it starts getting complicated quickly, especially when you're trying to mix a loopback address with remote addresses. And because Linux is much more diverse than Windows, the instructions are going to vary between different computers. Instead, I'm going to install HA Proxy and let it take care of things. I do realise that I am now load balancing a load balancer, and you could alternatively install a local instance of Nginx and configure that to get most of the same effect. Feel free to take the principle and do that if you prefer. I'm doing it this way because we've already got security filtering set up for OpenHAB in Kemp, and this keeps it all in one place rather than managing Layer 7 HTTP inspection in multiple locations. Install HAProxy. For me, that's DNF install HAProxy. Then edit the configuration file, which for me is etc/haproxy/haproxy.config. In the default section, just delete everything before the timeout queue. We don't want to do any Layer 7 stuff here, only forward the traffic to Kemp. If you're familiar with the options here, then tweak them as you like. Scroll down to the bottom and we're going to delete all of this front end and back end stuff and replace it with our own. Create a front end section with a name. I'm calling it OpenHAB Cloud. We'll tell it to bind to 127.0.0.1 using the OpenHAB HTTP port that is now free, and we'll tell it to use a default backend called Kemp. Now we need to create a backend section for Kemp. We'll tell it to use round robin load balancing, which doesn't really matter as we've only got one target for it anyway. Add a server called KempVS, or whatever you want to name it, and point it to the spare IP address on your network using port 8080. Save the file, use system control enable HAProxy to set the service to start automatically, and system control start HAProxy to start it running now. HAProxy will now catch requests coming from the OpenHAB Cloud connector and fling them out onto the network. Before we deal with this traffic, you might need to adjust the firewall on your OpenHAB server. If you've followed along with the series so far, you'll have locked it down to just HTTPS traffic, and for this we need it to accept HTTP. On Windows, if you've already got a rule to allow HTTPS, go back to Windows Defender Firewall with Advanced Security from your Start menu, find the rule you made previously, and on the Protocols and Ports tab where it should say local port 8443, add a comma and 8080, assuming you use the default port. On our Linux server, it's firewall command add port 8080/TCP --permanent, and then firewall command --reload to apply it. Again, if you change the port number, use it instead of 8080. Right, now we've hijacked the cloud traffic on either Windows or Linux, we're going to hop over to our Kemp Loadmaster to make it play by our rules. If at this point you're wondering what the heck this Kemp thing is, watch the previous video to see what it is and how we deployed it. In here we're going to add a new virtual service using the spare IP address we just forwarded our traffic to. This was the connect address in Windows or the backend server IP address in HAProxy. The port we used was 8080. This was the connect port in Windows or the backend server port in HAProxy. I'll call the service OpenHAB Cloud. Under real server, set the check method to the HTTP protocol. Click Add New and enter the OpenHAB server's IP address as the real server address, with port 8080 or whatever you've changed OpenHAB's HTTP port to. At this point, all we've done is create a big loop. Requests come from the MyOpenHAB Cloud service, pop out of the cloud connector, and get sent to localhost 8080, at which point we catch it and we throw it to Kemp, and Kemp sends it back to OpenHAB on its normal IP address. What's the point of that? The point is that it's now going through Kemp, so we can start applying some security to it. Remember the web application firewall from our last video? You can turn that on and scan the cloud traffic for threats. One thing you might want to do while you're in here is go to the advanced properties and click the access control button. If you add your OpenHAB server to the allowed addresses, that means nothing else can access this service other than the OpenHAB server. If you lock port 8080 on the OpenHAB server's firewall down to Kemp, that's a little bit more secure by forcing everything else in your network to use the encrypted port. That's by the by, the real reason for creating this loop is content switching. This lets us use rules that the MyOpenHAB service must now obey. For this, we head to Rules and Checking in the menu, then Content Rules, click Create Rule. The first rule is a special case and I'll explain why later. Call it All Devices. You can't have spaces in the name, but you can have underscores. For the match string, you will need to type, the first character is either called a caret or a circumflex or the hat symbol, depending on your particular allegiance. I'm going to say hat because it's the shortest, but for the avoidance of doubt, it's this symbol, and on my keyboard, it's above the number 6. So hat /rest/items/. Tick ignore case, just in case, and click create rule. Now we're going to duplicate that rule a few times. Click the duplicate button and we're going to pop over to OpenHAB and find the items we want to allow access to from our voice assistant. In OpenHAB terms, it's the item object we want. If you're using the semantic model, this will be the item that is linked to your point object. In this case, if I click through until I get to the switch for my living room light, I'll find the item is called livingroom_light_switch. If you've not exposed items through MyOpenHAB to your voice assistant before, you can do that here as well. In my case, I use Google, so I go to Add Metadata, then Google Assistant. I'd select Light as the class, and then if I click the Show Advanced button, I can give Google some information about the item. I'll tell Google to call it the main light in the living room and save. Back to Kemp though, the thing we actually need is the name of the item here. I'm going to append that to the match string that I duplicated. So my new match string is hat/rest/items/living-room_light_switch. I'll give it the name living room light and click duplicate rule. We'll repeat this for any item we want Google to have access to. The pattern will be rest, items, and then the name of the item from OpenHAB. Now let's head back to OpenHAB Cloud Virtual Service and scroll down to the real server. We're going to delete it as I only added it there as a demonstration. Then instead of clicking Add New, we'll click Add Sub-VS. A Sub-VS is a sub-virtual service. This is like virtual service inception, where one virtual service directs traffic to another virtual service instead of our OpenHAB server. Click Modify on the new Sub-VS and we can change its settings. You'll notice this looks just like the parent virtual service, so be careful to keep track of where you are. If you're confused at this point, we covered the virtual services in the last video, so maybe rewatch that. We'll give it a name, in this case I'll call it All Devices, and click Set Nickname. Then click back to return to the parent virtual service. Do this again and create a second sub-virtual service. We'll call this one Allowed Devices. On this we'll add our OpenHAB server to the sub-virtual service as a real server. This is just like when it originally added it to the parent virtual service. We need to do this in the other sub-virtual service as well, but to save time we can tick this box to add it to both at once. Now comes the magic. Expand advanced properties on the parent virtual service, and beside content switching, click the Enable button. You notice a new Rules button has appeared beside each sub-virtual service. Click that for the All Devices service, select the All Devices rule from the list and click Add. Then click the back button to return to the virtual service. The red warning box is gone. Now do the same for the Allowed Devices service. This time we're going to add all of the other rules to this service. You should end up with a table with each individual OpenHAB item listed. Do not add the default rule or the All Devices rule. Click back and let's talk about what we've done. In fact, let's demonstrate it using the Thunder Client plugin for VS Code. These rules control what traffic is allowed through the sub-virtual service. Ordinarily, the OpenHAB Cloud service has access to every URL on your server, but now we're restricting it to just the URLs we want it to access. If you try to connect to your dashboard from My OpenHAB now, it isn't going to work because we've not allowed it in our rules on Kemp. What we have allowed is access to specific items using the REST API. This is what Google uses to control your devices. Let me show you. If I perform a GET request to our OpenHAB server via Kemp using the URL we explicitly allowed for the living room light switch, we can see the state is currently off, which matches OpenHAB. If I then post that same URL and send the word on, the light switch switches on in OpenHAB. If I post off, it turns off. This is how Google interacts with OpenHAB, so our rules still allow it to control these explicitly listed items, but nothing else. Now what about that All Devices service? And why do we need sub-virtual services? Well, we didn't actually. We could have applied our rules to the real server directly instead of creating sub-virtual services, but, well, take a look. I don't know if Amazon works the same because I don't use it, but with Google, when you make changes to your devices, you need to tell Google to sync them. When you do this, Google makes a call to the same REST API, but doesn't specify an item name. As you can see, that gives it access to every device. This is necessary for the sync to go through when you've added new devices or removed old ones, but ordinarily we want to lock it down to just the devices it actually needs to control. That's why we have two sub-virtual services, because we can put the rule that allows access to everything in a separate service and hit the disable button. If I send another request to that URL now, Kemp says no. If I need to make changes and resync my devices with Google at some point in the future, all I need to do is click Enable, tell Google to sync, then click Disable again. And that's it! That's my solution! By redirecting the traffic from the My OpenHAB Cloud service through my Kemp Loadmaster, I can use these rules to restrict its permissions to the specific devices I want it to access. No need for full access, no need for general remote control, no need to open up the web interface. If all I want it to do is flip a light switch, then that's all it has access to do. If my cloud account gets breached, they could theoretically turn that light on and off, but they don't get any other access to my home. Here on YouTube, of course, I am much less restrictive. For example, I have given you full access to the controls to like the video and subscribe to the channel, and to watch the other videos in this series. If you're new to OpenHAB, start with this one, and if you want to know how to build secure remote access, watch this one. If you've already finished watching both of them, then check out my channel to see what else I do here. Thanks for watching, and I'll see you at the next one.